Okay, so number one here, we learned the quadratic formula yesterday, but we learned that if you just calculate this part, b squared minus 4ac, which is called the discriminant, you can know without doing the whole formula how many solutions there are and whether they're real or imaginary. So let's say a is 1, b is 4, and c is -2. So we would want to plug those things into this formula. I'm going to rewrite it like this because anytime we put a number where a letter was, we should have empty parentheses. So b again is 4, a is 1, c is -2. 4 squared is 16. -4 times 1 times -2 is +8, and so you're going to get 24. So if you remember from yesterday, if the discriminant is positive, so if it's greater than 0, there are two real solutions. Like if we graphed this, it would cross the x-axis twice. Just to recap all of it, if we had gotten 0 for the discriminant, like exactly 0, then it means there's one real solution. So we would have picked B in that case. And then if you get a negative number for your discriminant, it would mean there's two imaginary solutions. Like if you graph it, it doesn't cross the x-axis because the solutions are imaginary. So you would have picked E in that case. No, you would have never picked A or D, just a side note, okay? The three options are either there's two real solutions, there's one real solution, or there's two imaginary solutions, okay? All right, let's talk about this equation here. Guys, no matter what, usually we want it to say equals 0 when we're solving a quadratic equation, and this one does already, okay? Now, here's the thing about all the different methods we've used. The good thing about the quadratic formula is you can use it to solve any quadratic equation, okay? We can't always use factoring. However, you can use factoring on this. So if you can, you probably should, because factoring is a lot quicker than the quadratic formula. Like the quadratic formula is a lot of work, right? But I do want to mention real quick square roots. Like square roots aren't even possible for this question. Square roots are possible if we had an equation that maybe looked something like this, because we could just work backwards till the x is alone, right? See how it only has an x squared? If it's got an x squared and an x in it, because those can't be combined, you can't even use square roots unless you complete the square first. So that would be a lot of work. Okay, so I would always check to see if you can factor it first, which means reverse FOIL, right? Like, what can I FOIL out that would give me this back again? That's easy when this is a 1. So you would just put like x times x would give you x squared. Jump ahead and think about last. 1 times 10 or 2 times 5. Yes, oh my gosh, here's notes for today. And it would have to be 2 and 5 because that adds up to 7 at the same time, right? Like if I FOIL this out, x times x is x squared, outer is 5x, and inner is 2x. Together it equals 7x. 2 times 5 is 10, okay? If you're still not confident in your factoring, again, you just have to FOIL it out and see if it works or not, and it does. So that means the actual solutions, though, like some of you still just wrote this, you didn't tell me the actual things that make it equal to 0. So it would be -2 and -5. Maybe you just know. If you don't, you have to think, how can I get this to equal 0? Or how can I get this to equal 0, right? Because of that 0 product property we learned before. So x equals -2, which again makes sense because fill it in. -2 plus 2 is 0. Subtract 5 and we get x equals -5. Again, that makes sense because fill it in. -5 plus 5 is 0, okay? If you were to go through all the steps of the quadratic formula, you should get the same answer. So if any of you did solve it by the quadratic formula, you can know if you did it right by whether you got -2 and -5 or not, okay? I'm not going to go through the quadratic formula. So just to kind of summarize, guys, when I give you your next test next week, if it says specifically solve by the quadratic formula, that's because I'm testing to see if you know how to use the quadratic formula. If it says specifically, you have to follow the directions because I'm testing you on a certain concept. But this one didn't say, it just said solve the equation. So if it just says solve it, you really can use any of these methods you want. Just again, square root would be hard because you'd have to complete the square first, okay? But if you get a choice, I would always try to factor it first because factoring should be the quickest way to do it. Quadratic formula takes a little bit longer, okay? As we get into today's lesson, we're going to get a choice. That's why I wanted to go over that with you in the warm-up, that if it doesn't specifically say solve it by factoring or solve it by the quadratic formula, you can pick, okay? Today, 1.9, we're going to spend 2 days on this. Today, we're going to be graphing quadratic inequalities kind of like one-dimensionally, like we're going to be looking at the number line. So a couple of quick review things before we get into that. I'm going to draw a quick number line just because there's a couple of things that you need to remember from Algebra 1 here. Like if I wanted to graph all the numbers that were greater than 1, it would say x is greater than 1, but that's what it means. Make a picture of all the numbers greater than 1. Do you remember that we put an open circle at 1 because 1 itself is not included, right? 1 is not greater than 1. And then we kind of draw an arrow this way if we're making a picture of all the things greater than 1. Okay, you should have learned that back in Algebra 1. If it was greater than or equal to, that means 1 itself counts, like it's part of the solution set because we're graphing all the numbers greater than or equal to 1. So in that case, we fill it in. So this is kind of just a reminder that when you see greater than or less than without the like equal to in it, you're going to use an open circle because the number itself is not part of the solution set, okay? And then when it has an equal sign as part of it, you're going to fill it in because it is part of the solution set, okay? We'll talk about that more later on. So we're going to be graphing quadratic inequalities today. That just means if you look back at the warm-up, we had equations. That just means this, instead of an equal sign today, is going to be one of these signs. Those are inequality signs, okay? So the first couple of steps are not going to be anything different than we've already done. You have to move all the terms to the one side, just meaning it has to have 0 on one side, right? We know that. We've been doing that. And then you're going to solve it. Notice it doesn't specifically say solve it by the quadratic formula or solve it by factoring. So this is what I was talking about earlier. We get to pick how to solve it today, okay? So once you find the roots, remember roots is another name for solutions, you're going to graph them on the number line. And then the rest of this, I'm not going to really read it to you right now. We'll talk about what it means when we actually do an example in a minute, okay? But you have all the directions there on your handout. All right, so we're going to solve this again. Notice it's not an equal sign anymore. It's an inequality. It's a greater than sign. We'll get to that in a minute. It doesn't really matter right now because the first thing is one side needs to say 0. It already does, so we're good with that. And then this side, we're going to solve it like we normally do. Like we're going to kind of pretend like it is an equal sign for right now, okay? So how can we solve it? We're going to maybe try to factor it first, okay? So you stop and think for a second about, is there something I can FOIL out that would give me this back again? I'm going to let you think about that. Again, guys, factoring should be pretty quick if this is a 1 here, because it's always then going to be just x times x to give your x squared back again. Jump ahead and think about last. The only way to get 7 is 1 times 7 or -1 times -7, and they're gonna both have to be negative because of the middle term being negative. Again, if you're still not confident about knowing whether that's the right answer at all yet, you're gonna have to sit here and FOIL it out and see. X times x is x squared. Outer is -7x, inner is -1x, last is +7. And yes, this equals negative 8x. So yes, that's what we're looking for. This is the correct factorization, okay? Now, technically, this says greater than 0 right now. I want you to kind of pretend like it's an equal sign just for a minute, because we have to solve it like we normally would, like tell what the roots are or the solutions. So you might already know that it's positive 1 or positive 7. If you don't, how do I know that? Because I need to get this to equal 0, or I need to get this factor to equal 0. So add 1, and you would see x equals 1 is one of the solutions. Add 7, and x equals 7 is the other. Now, this is where it's going to start to get different because of the fact that it's not really an equals sign. It's a greater than sign. So we're going to learn a new process right now, okay? The first thing I want us to do is graph 1 and 7 on the number line. And you're going to do it with an open circle because of this, right? Remember what we just reviewed a second ago? Greater than or less than, you don't fill in the circle, okay? We'll talk about that more in a second. So I just want you to draw an open circle at 1 and an open circle at 7, okay? Now, I'm going to rewrite our inequality down here. X squared minus 8x plus 7 is greater than 0. So I want you to just listen for a minute. Put your pencils down. If I were to take 1 itself and fill this in and do the math, I would end up getting something that said 0 is greater than 0. No, it isn't. That's not true. That's why I'm not going to fill in 1, because it's not a solution. It doesn't work. Same thing with 7, okay? But here's the thing. Do you see how on the number line there's sort of 3 regions? Like, I'm going to call this region 1, this region 2, and this region 3, okay? So it's possible that some of the numbers in this region might be solutions, like the things less than 1, okay? So what we're going to do is we're going to pick a number less than 1. Like, we're picking a number from region 1. It doesn't matter which number we pick as long as it's less than 1. 0 is going to be the easiest thing to pick, because look, if I fill in 0 here in place of x, it's going to be easy math, right? Because 0 squared is still 0. Negative 8 times 0 is still 0. 0 plus 7 is 7. What we need to see is whether that's a true statement. Is 7 greater than 0? Yes. Okay, so what that means is that 0, the number we plugged in, is part of the solution set. That means if I'd picked another number down here, like negative 3 or negative 6, and plugged them in instead of 0, it would also still give me something true in the end, okay? So what we're going to do is we're going to draw an arrow going this way to show that anything less than 1 is part of the solution set. Like, again, I could sit here and plug in all kinds of different numbers less than 1, and it will always work, okay? We also have to test a point in region 2. So again, I have them labeled, but you can pick anything in region 2. I picked the number 4, but you could pick 5, you could pick 3.5. It doesn't matter, just anything in that region. Let's write out the inequality again. Okay, so like I said, I'm picking 4. So I'm going to plug in 4. And we just do the math, okay? You can really go plug it all in your calculator if you want. I'm going to show PEMDAS. I'm going to do the exponents and the multiplication. 16 minus 32 is negative 16 plus 7 is negative 9. Is negative 9 greater than 0? No. So that means all the points in here, we don't want to like shade that region because they're not part of the solution set, okay? So the same thing would happen if you plugged in 2 or 5 or anything else in this region, middle region here. It's not going to work, okay? Lastly, we have to test a point in region 3, meaning anything greater than 7. So I'm going to pick 8. But once again, you really could pick anything you want to. Okay, so I'm going to take the inequality one more time. And I'm going to plug in 8 this time because I just got to pick something greater than 7. Is that region of the number line is all this stuff greater than 7. So again, just do the math here. 8 squared is 64. Negative 8 times 8 is negative 64. 64 minus 64 is 0. So you end up with 7 is greater than 0. Is 7 greater than 0? Yes. So that means 8. Remember, that's what we were plugging in. 8 is part of the solution set. Anything else in that region, so like anything greater than 7 would also work if we tested it. Like, we don't want to sit here and keep testing it, but that's how it will work. Anything greater than 7 will work. So look at what we shaded to get our final answer. We're going to say x can be anything less than 1 because that's what graphing this part of the number line means. Anything less than 1 would work. If we plug it in here for x and test it, we'll always get something greater than 0. And then look at this part of the number line down on the right. That's all the numbers greater than 7. So x could also be something greater than 7. So this, we're kind of just writing what the picture on our number line shows. X can be anything less than 1, or it can be anything greater than 7. It can't be anything in between there. Remember when we tested a point in there and it didn't work, okay? So this is kind of our final answer. Okay, I know that probably feels like a lot for the first time, but do you have any questions so far? We'll do another one so you get the hang of it like we always do, okay? Step 1, you've got to have 0 on one side, just like when we've solved anything else in this chapter. So carry down your inequality sign. 6 minus 6 is 0. We're just going to write x squared plus x minus 6. How do you solve this? We have options. You can try to factor it. You can use the quadratic formula. I would always try to factor it first, and if you can't figure out how to factor it, then go use the quadratic formula. But you try to factor it. I'll give you a minute to do that. So again, when this is a 1, it's always just going to be x times x. Jump ahead and think about last. What are the ways to get negative 6? Maybe it's 1 times negative 6. Maybe vice versa. Maybe it's positive 3 and negative 2. That is what it is. Okay, I'm not going to show it again. If you FOIL this out, it's right. Like, it equals this, okay? Now, again, it's not really an equation, but let's pretend for a minute it is, because we have to find the roots or the solutions, which hopefully you know already would be negative 3 and positive 2. But if you don't, again, you have to ask yourself, how can we get this to equal 0? Or how can we get this factor to equal 0? And you just solve it, right? So x would have to be negative 3, or x would have to be positive 2. So again, those are going to be kind of your starting points on your number line. We're going to graph dots at negative 3 and 2. They're going to be filled in this time because it's less than or equal to. Like, if I take negative 3 itself, let me rewrite the original inequality. X squared plus x is less than or equal to 6. Like, if I take negative 3 itself and fill it in, what's going to happen is the inequality will say 6 is less than or equal to 6, which it wouldn't be true if this wasn't there, right? If it just says 6 is less than 6. But since it's 6 is less than or equal to, then it works, okay? So that's why we fill it in. 2 would also be part of the solution set, so we're actually going to fill it in, okay? And then once again, we need to know, because it's not an equal sign, those aren't the only 2 answers, okay? We have to test, like, do the points down here also work? Do the points in between here work? Do the points up here work? There's 3 regions that we're going to have to test like we did in the last one, okay? So I'm going to test negative 4 in this first region, like to the numbers to the left of my first dot. I'm going to pick negative 4. Again, you could pick -5, -6. It doesn't matter. You can pick anything to the left of your first dot. -4 squared is +16, right? -4 times -4. And then 16 minus 4 is 12. Is 12 less than or equal to 6? Nope. So I'm not going to do this because those points aren't part of the solution set. We got something false. I'm going to just put an X there because it didn't work, right? Or cross it out. The points down there don't work. Test a point in here to see if it works. Doesn't matter which point you pick. So guess what? 0 is the easiest one to pick. I'm going to rewrite this again. X squared plus X is less than or equal to 6 was the original problem. I'm testing to see if 0 works. 0 plus 0 squared is still 0 plus 0. Is 0 less than or equal to 6? Yes, it's less than it. So guess what? If 0 works, all the points in here will work, okay? Lastly, we should test a point up here to see if it's going to work, like the things greater than 2. Will they work? So I picked 3. You can pick 4, 5, 6, 7.5. Anything to the right of this dot is what we have to test. So I'm going to write this out one more time, and I picked 3 to plug in. Guys, again, it has to be to the right of the dot. Don't pick the actual dot because we already know that works. That's why we filled it in, okay? 3 squared is 9. 9 plus 3 is 12. 12 is less than or equal to 6. No, it's greater than 6. So we're not going to graph the points up here because they don't work. They're not part of the solution set. So since the solution set is this region right here, we're going to talk about how to write our final answer for that. Guys, remember on the last one how our graph had 2 separate branches? It was all the points down here, so we had to say x is less than 1, but then it was also all the points up here, so we had to say also that x could be greater than 7. It's just one region this time. Like it's all the numbers from -3 to 2. So if you forgot how to write that from Algebra 1, we say x is greater than or equal to -3, but less than or equal to 2 at the same time. Like the smaller number goes on the left, the larger number goes on the right, x goes in the middle because it is like it can be any number in between -3 or 2 or -3 or 2 itself, okay? So that's how you're writing an inequality that describes the picture you drew, essentially. X can be greater than or equal to -3, but less than or equal to 2 at the same time, okay? All right, put your pencils down for a second because I'm going to teach you a little shortcut. Those problems feel really long right now, but fortunately, I want you to pay attention to the answer. Do you see how this time our answer was the middle region between the 2 points? Bless you. And on the other one, it was everything but the middle region, like it was the lower region and the upper region. Usually, that's always going to happen. So it's probably a pretty safe bet that you don't have to actually test 3 points, because if you test 1 point in here and it works, probably it's going to work up here too, because usually these go hand in hand. Like if you shade this section, you're probably going to shade this section too, okay? And then down here, like if this didn't work, it's probably not going to work up here either. It's probably the middle section is going to be the answer, okay? So that will be kind of a shortcut to help us out when we look at future questions, okay? Let's go on and try another one. So again, it's got to have 0 on one side. So we've got to get rid of this 15 first thing so that it says 0. We're just going to write x squared minus 2x minus 15. I'm going to give you how do we solve this. Again, there's options. We could use the quadratic formula, but maybe we can factor it. So we should try that first, okay? Go ahead and take a minute and see if you can figure out how to factor it. Again, hopefully we're getting pretty quick at factoring when this is a 1, because x times x is x squared. Jump ahead and think about last. What are the ways to get -15? 1 and 15, but one of them has to be negative, or 3 and 5. We'd have to have a -5 and a +3. I'm not going to FOIL it out, but if you're not sure whether that's the right answer, you should FOIL it out. You would see that it gives you this back again, okay? So just for a moment, again, let's pretend this was an equals sign, because we have to find the roots, which, again, hopefully you know already that it's +5 and -3. But one more time, if you don't know, you have to ask, how can I get this factor to equal 0, or how can I get this factor to equal 0? So we would solve those. We would add 5 to both sides. So 5 would be one root, and then take away 3. -3 would be the other root. So again, because it's not actually an equals sign, though, let's change it back. It's actually a greater than sign. So we're going to start by graphing 5 and -3, but we're not going to fill them in because of the sign. It's greater than. If it were greater than or equal to, we would fill it in. We're not going to fill it in, okay? Because again, let's write out the inequality. I want you to understand this. If I plug in -3 and check it, it's not going to work. If it did, we would fill in the circle, okay? So let's try to think about the shortcut. Do you remember I told you that usually all the points down here and up here are going to be the solution, or the middle is going to be the solution? It's usually going to be one or the other, okay? So let's check and see. 0 is the easiest thing you can possibly check. That's why I picked 0 first, okay? So let's plug in 0 and see what happens. 0 squared is still 0, minus 2 times 0 is 0. So that's why easy math, right? Is 0 greater than 15? No. So that means we don't want to shade in here. That's not, 0 is not part of the solution set. That probably means that all the numbers less than -3 and all the numbers greater than 5 are going to be solutions. If you want to be safe, you can go check it, but that is how it's going to work. Like if you test -4 and you test 6 or anything else in the region, it will work, okay? So the solutions are going to be any number less than -3. So we're going to say x is less than -3. But it could also be anything greater than 5, so we have to say, or x can be greater than 5, okay? Again, if you don't believe me, you can sit here and test a number in both of those regions just to make sure. And if it were a test or quiz, you might want to, because there are once in a while some special circumstances where it could be like, this would also work, like the entire number line could be a solution, okay? But not very often does that happen. Usually it's either going to be region 1 and region 3, or just the middle section. Okay, questions on that? Let's look at another one so we get confident here. So this already has 0, so we're good with that. So how can we solve this? We can either try to factor it or use the quadratic formula. Go ahead and take a minute and think about whether you would be able to factor it. It will be a little harder this time because it's not x squared, it's 2x squared. Okay, but I'm still going to let you think about it and see if you can factor it or not. If you're trying, I put up a new slide real quick, because if you're trying to create, factoring means make up a FOIL problem, right? If you're trying to do that, you shouldn't have been able to find anything that works, because no, I set it up already, because the only way to get 2x squared is 2x times x. But let's jump ahead and think about this. Maybe it could be -1 times +4, or maybe the 4's here and the -1's here, or maybe it's not even 1 and 4, maybe it's 2 and 2. So again, you just have to FOIL it out and see. We already know that all of these have a first and last of 2x squared and -4, because we purposely set it up that way, right? So just check the outer and inner. This gives me an outer of 8x and an inner of -1x. Together, that equals 7x. That's not what I'm looking for. I need it to equal 1x. 2x times -1 is -2x. Inner is 4x. Together, that equals 2x. That's not what I'm looking for. I need 1x. This would give me +4x, and negative 2x, which equals 2x, not what I'm looking for. This cannot be factored. So guess what? You're going to have to use the quadratic formula if it can't be factored. You could use square roots if you complete the square first, but that's way too much work. So we're gonna use the quadratic formula, okay? So x equals the opposite of b plus or minus b squared minus 4ac over 2a. You go ahead and fill everything in. Quadratic formula is still up on the whiteboard if you need it. I'll write it here too. So go on a couple steps by yourself. There's how you should have filled it in. Opposite of 1 is negative 1. Underneath my square root, 1 squared is 1. Negative 4 times 2 is negative 8 times negative 4 is positive 32. 2 times 2 is 4. I'm going to come up here. We're going to have negative 1 plus or minus. 1 plus 32 is 33. Guys, put your pencils down real quick because I'm going to teach you a cool side note. Look at my discriminant. Remember, that's what the b squared minus 4ac is called. See how that number is not a perfect square? Like, if it were 36, that would have been really nice because the square root's just 6, right? Whenever it's a perfect square, that means you could have actually solved the problem by factoring. But this is a way to kind of confirm this cannot be factored if that's not a perfect square. Just a little side note, okay? You don't really need to know that. It's just a helpful tool that you know, yeah, this is good that I'm doing the quadratic formula because I have to. It can't be factored, okay? So the square root of 33, normally we check if it can be simplified, but it can't. So let's talk about our two solutions. So one of them would be negative 1 plus radical 33 over 4. And the other one would be negative 1 minus radical 33 over 4. Yesterday, we kind of left it like that, right? But because we have to graph these things on the number line, you're going to want to look what they look like as decimals. I'm going to talk about how to punch this in your calculator, okay? So pick up your calculator with me. There's a couple different options. Probably the best option is to do alpha and the button right next to it to get a vertical fraction, or alpha y equals, so this little menu type comes up. Because if you type it vertically, negative 1 plus radical 33 over 4, let me tell you what happens instead if you're going to type it sideways. Just watch for a minute. If I'm going to type it like this is wrong. You're going to get the wrong answer because your calculator will only do radical 33 over the 4. Remember how the whole thing's supposed to be divided by 4? So you either have to just like type just that part and then divide it by 4, or you could put parentheses around this so your calculator understands it has to do that first, like, because the whole thing has to get divided by 4. So the answer's around 1.2. So let's write that down for a minute. Okay, that would be around 1.2. And let's go ahead and graph that on the number line. That'd be about right there. Remember, we're using a filled in circle because of it's greater than or equal to. Whenever it can be equal to, we fill it in. So then another cool trick about your fancy calculator, if you already typed this in, if you just go up and select it, just go change this to a minus sign now, so you don't have to retype the whole thing. It's going to be about negative 1.7. So we'll write that down. I'm going to kind of write it in parentheses, okay? And we're going to go graph it. Negative 1.7 would be about right here, almost to negative 2, right? And then again, we got to check, like, maybe also all the things less than this and greater than this work. Or maybe it's all the things in here that work. The easiest thing to do is test 0, remember? So let's take our inequality, 2x squared plus x minus 4. If we plug in 0, let's see what happens. 0 squared is still 0 times 2 is still like you're just going to get 0 from all of this, okay? So negative 4 is greater than 0, greater than or equal to 0. Is it? Is negative 4 greater than or equal to 0? No, it's less than it. So we don't want to shade this section because 0 is not part of the solution set. Again, you can pick a number down here if you want, but it's going to work. You can pick a number up here, but it's going to work because if the middle section doesn't work, the answer is going to be all the things less than or equal to this number. We're not going to write negative 1.7. We're going to write it like it was like in the radical form, okay? Or anything up here, meaning anything greater than or equal to 1.2, but again, we're going to write it in the radical form. So negative 1 plus radical 33, just like you did on your homework yesterday, right? When we write our answer, we don't give decimals. We just had to do that so we knew what to graph on the number line, okay? Okay, on this last one, let's get it to say 0 first. I want you to spend some time and see if you can figure out how to factor it or use the quadratic formula. You pick which one you want because guess what? This one can be factored. So if you want to factor it, you can. If you don't, go ahead and just use the quadratic formula. You pick what you want to do, okay? So if you factored it, here's what you should get. Again, I'm not going to go through it, but just FOIL it out and check it, and it works. You would have to see what makes it equal to 0, though, right? So 2x plus 1 equals 0, x minus 4 equals 0. Solve both of those things, okay? Or if you went through the quadratic formula, I wrote out the work so you can check that. Guys, look what happens. We get a perfect square this time. Remember my little trick? That's how we know it could have been solved by factoring. So guys, when it's a perfect square, the square root of 81 is just 9. Like, this is easy math. Just do 7 plus 9, 16 divided by 4. So 4 is one solution. 7 minus 9, so negative 2 divided by 4. Negative 1/2 is the other, okay? You would get the same thing if you solved this and if you solved this. So again, you're going to put open circles at negative 1/2. That was not very good. Right in the middle it should be. And positive 4. And you're going to test a point, okay? So like we could test 0, remember, is the easiest. If I recopy this and I fill in 0, 4, and I test it, because you're going to have a bunch of zeros here, it's just going to give you 0. And this says 0 is greater than 4. No, it's not. It's less. So I'm not going to shade here because that's 0 is in the middle section. I'm going to shade all the things less than negative 1/2 or all the things greater than 4.